Okay, so this is a chemistry question for Sarah. She asks, with the balance equation given, and this is for the combustion of benzene, which is C6H6, nice little ring of carbons. When you burn that, um, how much energy do you produce? And in this specific question, if you burn 6.6 grams of benzene, uh, and the heat produced is added to 5,691 grams of water at 21 degrees Celsius, what will the final temperature of the water be? So just to save some time, I started off with a couple of things that we'll walk through at the beginning. So at the very beginning, we have our primary equation that we're going to use to solve this problem, which is Q, where Q is the energy, equals mc delta T, the MCAT formula. So M being the mass, in this case of water, C being the specific heat capacity of water, which happens to be 4.184 kilojoules per degree Celsius that you're going to either heat up or cool down the water. And that's just something you can look up in any textbook. One quick Google search will do it for you as well. And then the initial temperature that we're going to use to find the final temperature, which is given to us as 21 degrees Celsius. So first thing we have to do, if we have 6.6 grams of benzene, we need to figure out how many moles that will be, because that factors into how much we're going to actually burn, and therefore will tell us how much energy we're going to get out of that. So to go from grams to moles, we just divide by the molar mass, which is 78, and that gives us 0.0845 moles of benzene. Now the next thing, and this is another number that you can just look up, it's the heat produced from the combustion of benzene. This should be a textbook number that you can look up fairly quickly, and that happens to be negative 3,267.6 kilojoules per mole of benzene, with the negative just indicating that it's an exothermic reaction, i.e. it's producing heat. Things are getting hotter when you burn something, obviously. So from here, we're going to do all the calculations. So if we only have 0.08 moles, we're going to multiply that by the amount of energy produced per mole to get the total amount of energy. So for this reaction, if we only have 6.6 grams of benzene, that means we're only going to produce about 276. Let's just say 0.1, if we round up, kilojoules of energy. So if that's all we've got, now we can just plug that right into our equation here. So just to save some time, let's go ahead and calculate the delta T right away, and then we're just going to subtract the initial temperature to get our final answer. So if we take that 276 and we divide it by the mass, which we want in grams, so 5,691, and then divide that by the specific heat capacity, which is already in kilojoules, which is what we want, 4.184. That gives us a change in temperature of just 0.0116 rounded degrees Celsius. And since we know this is an exothermic reaction, it's fairly simple to get the final answer. So that tells us our final temperature will just be a little bit warmer than it was before, which makes sense. Water is very good at absorbing heat. So that gives us 21.0116. And the number of significant figures I'm using here is completely arbitrary. If you want it exactly correct with all the sig figs, I didn't go through those just based on the amount of time we had. Your final answer, depending on how your teacher likes it, could just be 21 degrees, since that first, or I should say that third digit after the decimal is just 0 anyway, and it would round down. But this is a good, fairly decent approximation here. So if you have any questions from there, definitely leave a comment. Otherwise, hope that helped, and best of luck with the rest of your work.